if you fall behind or if you need a fresh clone for whatever reason, we'll go over starting with a fresh clone of the existing repo. So you can actually just jump straight into, which repository is this? The Pokemon application repo. Let me switch screens real quick. It's hard to see. And from here, you'll see that there is actually a branch for every existing day. So end of day 2 will cover all the progress that was made up to day 2, and this is where we'll be starting today. So if you fall behind or your folder gets messed up for whatever reason, you could just create a fresh clone of this repo and work from there. But there are a few caveats. You'll have to reset up your environment. You'll have to make sure you switch to the right branch, and you will have to install the requirements.txt file. So let's switch back to the other screen, and we'll walk through that really quick. So today we'll be covering setting up a fresh clone, implementing both built-in and custom validators, and then creating and running Django tests for models utilizing these validators. And from there, you can all work on School API number 3. So setting up a fresh clone. The first step will be to, of course, set up a clone, switch to the proper branch. You'll want to make sure you run git switch and add to the end of that command the branch that you want to work on. Once you've done that, you can cd a directory up and create a virtual environment using python-m venv, adding that exact same folder name to the end of that command. You then use source to activate that virtual environment. Next, you will run pip install, make sure to pass in the -r flag and the name of the requirements file with all the requirements that that the application requires, that the project requires, I should say, actually. And from there, you could run Docker Compose to spin up your database, and then you will be good to go. Any questions? Cool. So the general steps to creating database models in Django. You create your models, and then you add validators that you'll be utilizing to test your models. And then you test your models. There are migrations. You can make migrations, but I think Chad may or may not cover it this Saturday. Originally, Chad was going to cover migrations with you, and he still might, but he also feels that migrations can cause a lot of pain with very little payoff, so he might skip over it altogether. You will find on Saturday. Today, we're really only worried about adding validators and testing models because we've already got our models created. So you could add either a built-in validator or write your own. For the first part of this demonstration, we are going to, yes, Damon, we will be coding this out. We're just going to run through it real quick, and then we will code it out. So we are going to first import the validator class into our model file, and then we will be adding a validation for a simple description field for our Pokemon. And in this example here, we have, as you can see, a minimum length validator, which we are pulling from our validators class, which we've given an alias of V, and we also have a max length validator. So any description outside of this range should raise a validation error. Next, creating a custom validator is as simple as creating a validators.py file and defining your validations from within. Of course, after you import some classes, such as validation error and RE for checking against regular expressions. The validation that we will code out will look just like this. Let's run through it really quick. We have a definition, and we're passing in a parameter name. We set an error message to improper name format, and we have the regex that we want to check against. We create a Boolean based off whether the regex matches the name that is passed in. And if this Boolean returns true, we pass the name back. Otherwise, we raise a validation error with the error message and parameters such as name. Once you've written out your validator, you hop back into your models.py file, and then you import that validator. And then somewhere within that file, you'll want to call that validator that you wrote. Next, we'll be testing the validator inside a tests.py file. Again, we add our imports, we write out some tests. In this example, we have a new Pokemon, which we are instantiating with the Pokemon class. We're giving it a name of Pikachu and a description. It's cut off, but at the end is also the third parameter that's required, which we'll get to when we're actually coding this out. And then there's a try block, which will run the full clean method. This full clean method is necessary for these validations to run. And we're going to assert is not none, passing in this new Pokemon that we've created to make sure that it is not an empty object. We'll create an exception with an alias of E, and basically this will call a failure if this test fails. We'll have a second example, and let's just actually jump right into it as opposed to running through this one more time. I'm going to switch screens. This should be the right screen. Is this? Okay, cool. All right. Let me know if my text is too small, but if it's fine, I have a fresh clone of the Pokemon example repo, and from here, you can see we've got our models file. This is the models file as it should look for you after completing yesterday's exercise. And this is where we're going to start to write out some validators. Okay, so the first thing we're going to want to do is, can anyone tell me?
Import the validator?
Yes, exactly. We want to import our validators. So let's write from Django.core import validators. We'll give it an alias of V. From here, we want to actually create a validation that's going to utilize one of the built-in validators that you can reference. I should have showed you this link. I'll show you this link afterwards, but there is a link in the README that will point to the official Django project documentation, which has a list of all the built-in validations that you can use. In this example, we will be creating a description, and we will set it equal to models.text field because we want our description to be a text field. We're going to have a default of unknown, and we will then create a few validators, the validators being a min length validator and a max length validator. Let's give it a minimum length of 25 and then a maximum length of 150. So if we were to give a description to one of our Pokemon that falls outside of this range, we should see a failure. Before we get to writing the test, let's go over writing a custom validator. A custom validator is simple as writing a validation inside of a validators.py file. Just like with the built-in validators, we have to import some of the things that we want to use. In this case, we want to use a validation error. It's a built-in class. It's what we are going to raise if there is an error. And then we're going to import RE so that we could check against regular expressions. The validations that we want. Let's start with a name validation. We are going to use this to make sure that our name only has proper just alphabetic characters. We don't want mirror characters. We don't want punctuation. So we're going to set a parameter of error message. We're going to set it to improper name format. This is the message that will be returned by the test if the name passed in does not match the regex that we are giving it. So improper name format, and then let's create some regex. And this up caret will signify that we want to start a string, and then we want to denote that we want a single capital letter at the beginning of the string. From there, we want to allow for lowercase letters, and we don't care how many as long as it fits within the length of the name defined inside the models. And then we use $sign to denote the end of the string. So from here, we create a Boolean such as good name, and we will base that Boolean off of a regex match between the regex expression that we defined up here and the name that we are passing in. Now let's create a conditional. If this Boolean returns true, then we will pass back the name. Else, we will raise a validation error. That validation error will have the error message, and we will create a dictionary containing the name. Okay, this should be good. Let me save this. Now we want to go back to our models file and just want to make sure. Okay, cool. Yeah, it's still sharing. Now that we're back in the models file, we can import the custom validation. And we called it, so we're gonna pull up that validators file first. And then we're going to import from that file, what do we call it? We called it validate name. And from here, we just need to call this validate name wherever we want to run the validation. And in this case, we want to validate the name, so we will call it from within name. So we're listing out the validators that we want to use for name, and the only one we're passing in is validate name. From here, we could start to write our tests. So first things first, we're going to import some additional things that we need, including the validation error. We will then import from our models file the Pokemon class, because this is what we are testing. Now let's write out some tests. Our first test is going to be creating a Pokemon. So let's say create Pokemon instance, pass it in self, and we will say new Pokemon will equal Pokemon of, let's say, Pikachu. And we have to give it a description that is over 25 characters or whatever it was that we wrote. We wrote 25 here, so we have to give it a description longer than 25 characters. Let's say Pikachu is an electric type. What is he? A mouse or something? A Pika? This should be enough characters. Actually, no, it shouldn't be. What did Chad write? Chad wrote only the best type Pokemon. Only the best electric type Pokemon in the show, but not in the game. Chad's opinion, not mine. Next, we want to also make sure we are passing in, what parameter is this? A captured parameter, because inside of our models, we have a captured Boolean field. So this cannot be empty. So we'll give it a captured value of false. All right. Now that we have our Pokemon created by the test, we want to try some validations. So first things first, we have to use that full clean method that I mentioned earlier. This essentially wipes out the data before running a test. And this is also what will initiate the running of the validator. We'll then add a self.assert is not none because we want to assert that this is not an empty object and that these parameters that were passed in were actually generated. So if it passes both of these, if it passes this test, then we should receive pass. Otherwise, we want to define an error to raise if the test fails. So let's say if for whatever reason an error comes up, then we will call a fail. Let's see what happens if we run this right now. So you'll be hopping back into your repo, and then you run into the root directory where there should be a manage.py file, which is what you use to run your Django magic. And in this case, we will be running it with the test command. Yikes, it looks like it found 0 tests. Let's see what is going on. Let me make sure I'm in the right location. Oh, I am on the wrong location. All right, let me exit out of this. I'm going to deactivate. I'm going to exit out of here. I'm going to hop into the right location. I'm going to source this location, bin activate to activate my environment. I am going to jump into this directory. Now I should be able to call manage. Yikes, it looks like it found 0 tests again. So let's see what is going on.
You have to import the test file into the models file? Is that a thing?
I might. Let me double check. There's validators, there's validate name. Oh, I did not actually define a class. I forgot this line, so we're gonna define a Pokemon test. We are going to use test case, and then we are going to indent this because that's how Python likes it. Now let's try. Nice. So this test ran and it passed the test. Otherwise, this period here would appear as either an E or an F. So let's say, for example, we had a description that didn't match the length of whatever we said. Pikachu is an electric Pokemon. And let's now try running our test again. It looks like it actually passed the test because we didn't really, right, we only wrote this test to assert that the object is not empty. Let's try creating an empty object then. Or let's pass something that doesn't exist. All right, let's see. And we have a failure because our assertion failed. We had the assertion that this object is not none, but of course this object is none, so the test failed. Just as we wanted to. So let's get rid of this. Let's set this back to what it was originally. And let's write another test. Right, test 02. This test will create a Pokemon with the incorrect name format. Again, we're going to pass itself. We're going to create a new Pokemon instance within this test. And let's say this time we are going to create Charizard. Except we don't want to, well, let's leave it as Charizard for now. We'll give it a description. It's like a dragon, has wings, breathes fire, but is not a dragon. And we want to set a captured parameter to false. We are going to try new underscore Pokemon dot full clean. We are going to try, what this is going to do is if this exception does not succeed or is not called, how should I say that? If this exception isn't raised, there we go, then we will call a failure because that's an indication that our test itself failed. But what we really want to try to do is either raise an error or raise nothing at all. So we're going to write except, we're going to use validation error again. We'll give an alias of E. And this time, let's make the assertion that improper name format will be passed back from the custom validator that we wrote earlier today. So it will be within the validation error object, which we've given an alias of E, and it will exist within the message dict under a key of name. So now let's try running this test. So we received 1 succeed and 1 fail. The first test succeeded and the second test failed. The second test failed because we set it to fail. And this is exactly what we wanted, because what we're trying to write this test to do is to compare an improper name, which we did not receive because we passed in a proper name. So now let's try passing in an improper name, because that's what we're actually testing for. So let's say, I don't know, let's give it some numbers. And let's give it some punctuation. And now let's try running the test again. Now we have 2 successions. The first test succeeded, and so did the second test, because what we were testing for is true. We were creating the assertion that if an improper name is passed in, then a validation error will be raised, just like how we wrote within our validation, our custom validation. And that is essentially the gist of writing custom validators and testing custom validators. Does anyone have any questions so far?
Yeah, I actually have 3 questions.
Sure.
The first one, if you go to the models file all the way to the top, I imported all of them. I did Django core validators, import star. Is that bad practice?
Well, yeah, generally it's bad practice, because if you're not going to be utilizing everything inside that library, you're importing them for no reason.
Okay. I just figured the built-in library is fairly small. So okay. And second question, the self.fail. I was looking more into that, and it seems like the full clean validates everything in there, and should, if there is an error, should induce it without the self-fail. It seems like the self.fail is a backup from what I was reading.
Right. In this case, I think the way that Chad wrote this test is if we don't have the self.fail, let's try running the test. What might happen is it might pass the test. And so see, we have it pass both tests. But if we were to give it a proper name, so let's change this back to Charizard and run the test again. We should still get 2 passes. And I believe this is because what's happening here is we're creating this assertion that the improper name format exists within the validation error, except a validation error is never raised. So it really kind of boils down to how the validation itself is written. So yes, like you say, it's kind of like a fail-safe in this instance. That's how Chad wrote the test, basically.
Okay. my last question is for the built-in validators.
Mhm.
The documents show you can have multiple options, including like a message. So if your class gets convoluted with your validators, if you actually stick them in like right there, would it be good practice to just store them in variables and put the variables in there? Does that make sense?
That makes sense. But I still don't really see the benefit to that. So like you're saying in this example, right? Let's say we want a min length to equal v dot min length validator, and we'll pass it that value 25. So instead of passing this in, we have min length, right?
Yeah, but if say for instance you use email validator built in Django, you'll have your regex, which could be long. Then if you two sentences for your message and maybe one other option. I don't know if that if you had 10 of them in your class, it might get a little convoluted.
That's very true, actually. That is very true. And in this case, if you were writing the code yourself, what you're thinking is a very good idea because it will give the code some legibility. Now, the caveat is wherever you end up working will very likely have their own set of standards to follow. They'll have style guides, and those are essentially going to be the rules that you follow ultimately. So if wherever you land follows that practice, you'll want to follow it as well.
Okay, thanks.
Cool. Anyone else have any questions?
Yeah, I had just a quick one. I think I'm understanding it right, but like when we import from Django core, like those are the built-in validators, right? And then we need to make a validators.py or some file where we're going to have our validators to import to do any custom ones.
Exactly, yes.
Okay.
And within that custom validators file, you're still importing from the library. All right, so if there are no more questions, let's take a quick look at the exercise. Actually, I'm just gonna double check the chat. Okay, cool. I'm gonna switch screens. I have way too many windows open. Okay, I think that's the right one. So in this assignment, you'll be extending the student models application, and you will be writing some validations for it. So the way it's set up, you've got a test.py file, and from there, you will want to create these custom validators, of course, in your own validators file, and then you want to add your tests to the tests file and run them from there. I don't know if you were working on these projects individually or in groups. When was the last time you all worked on school API #2, and were you in groups?
We weren't really, we were in groups, but not really like, we were in 2 different groups each day. So we're not in specific groups.
Okay, not in specific groups, but basically you were just in breakout rooms.
Yeah.
Okay, cool. I'll set up some breakout rooms for this then, and Tiffany and I will be around to answer any questions. This is the only challenge, so we really can just spend the whole night working on this, and we'll just check back in at 9:15. How does that sound? Cool.